complete the square of a general quadratic, which again, I'm not going to go through that whole thing. I'm going to put the other videos on there for you to see that. And you can have that comprehensive, and your book also has a comprehensive derivation of the quadratic formula. And it's basically the same idea as just completing the square. So what we end up with is that x can be written as, and you might have had a song or something about this, negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So let's use this and solve an equation. Now, when we're using the quadratic formula, we want to go back to 0 on one side, everything else on the other. So I want to subtract 3. I don't want to divide. I want to subtract 3 from both sides. So 5x squared minus 8x minus 3 equals 0. And I don't think I can factor it, so I'm going to go ahead and use the quadratic formula. So let's remind ourselves. Negative b plus or minus the square root of b squared minus 4ac, and all this is over 2a. So what is a? A is 5. B is negative 8. And c is negative 3. Because once it's on this side, it's negative. So let's plug this into the formula. So x is equal to negative 8 plus or minus the square root. Make sure your negative 8 is in parentheses. I cannot stress that enough, that if any of these are negative, when you're putting them into the formula, put them in parentheses. Squared minus 4, 5, negative 3. And that's over 2 times 5. Now this looks daunting, but it's really not that bad. Negative 8 is just 8, plus or minus the square root. Negative 8 squared, and that's why I want you to put this in parentheses, because negative 8 squared is 64, positive 64. And had you had that 8 hanging out, you might have made a mistake. 64. Now we have a negative and a negative. If we have even number of negatives, you learned in 055 that that is a positive. So plus 4 times 5 times 3. So that's 20 times 3, which is 60 over 10. So that's equal to 8 plus or minus the square root of 124 over 10, which equals, well, let's see, let's do this separately. 8 over 10 plus or minus, let's see, I'm seeing that the square root of 124 can definitely be divided by 4. Maybe even 16. What's 124? Or not, or 12 maybe. No, wait, not 12. Divided by 4, what do we end up with? 31. Yeah, I think that's about it. So remember, this is going to be the square root of, pardon, 4 times 31 over 10. So 8 over 10 can be 4/5. Plus or minus 2 times the square root of 31 over 10, which this becomes 1/5. So I have 4/5 plus or minus the square root of 31 over 5. And that is the most simplistic way that I can actually do that one. I could write it out. I could approximate it, 0.8 plus root 31 over 5, 1.914, or minus negative 0.314. So here's my approximations. But you know what? If I wanted to get approximations, I could have just put this thing in the calculator in the first place, and I could have gotten approximations. So I kept this example in here because it was important. I wanted to have an example. Most of the examples I changed into problems to do in class with you. So one projection of the world's population by United Nations is given in this table. I didn't put the table, so it's okay. The data can be modeled by this. X is the number of years after 1990. In what year after 1990 does this model predict the world population will first reach 6,702,000,000 people? So let's see what we have here. So remember, this is in millions. So we can actually take off these 6 zeros. So we want to see, when does negative 0.36x squared plus 38.52x plus 5822.86, when is that equal to 6702? So let's go to our calculator, because I'm not going to do that by hand. I can, I just choose not to. And let's go into that. So negative, you know what, I'm just going to clear this. Let me make sure I get it right. Negative 0.36x squared plus 38.52x plus 5822.86. Then my other one's going to be 6702. Now I need to know where to make my window, because I don't know where to make the window at this point. So let's figure out what the height of this graph is going to be. So what is the height? Negative b over 2 times negative 0.36. So let's see what that is. Negative 38.52 divided by 2, oops, got to put this in parentheses, 2 times, or would have been multiplied by that, negative 0.36. So the height is 53.5, or that's the x coordinate of the vertex. Okay, so now let's see what the y coordinate is. Let's go vars, y vars, function, at 53.5 is 6853.27. So we want a function that goes at least that high. So let's get our window. So x-min, I don't think we need to go before 1990, so let's just say 0. We need to make sure and cover 53.5. I want to double that, actually, so I'm going to go to about 110. I think my scale I'll make 10. And y-min, well, definitely don't need to go anything below 0 at all. And I know this is the maximum is 6,853,000,000. So I'm going to say at least 7,000. We'll make this 500 to make it look nice. And let's graph it. And we can see the intersection. Now we can make that window a little bit higher if we like, just to be able to see that a little bit better. Yeah, that's still not very good. We're going to have to come in with our y-min a little bit. So let's just make that, and I think this will zoom it in enough where we can see it well. I don't like to not show the x-axis, but still, these are so close together that it's difficult to see. So let's go ahead and do that now. And it says, will it first reach this? When will it first reach it? So we actually want this intersection right here. So let's go and let's do our intersection. Number 5, first curve, second curve. And my guess is And this one's a little hard to see. I'm going to say right there. So it looks like my intersection is at x equals, oh, we're going to act weird. Don't you love OneNote? X equals 33. So if x is 33, that's the number of years after 1990. So 1990 plus 33 would be 2023. So there you go. That's the easy way. There's other ways to do the problem, of course. You can subtract 6702 from both sides, use the quadratic formula, or you can find the zeros. Either way, but with an applied problem like this, your best bet is to use your calculator. So let's talk a little bit about the discriminant, and this is kind of an important piece of the quadratic formula. So d equals b squared minus 4ac, that's the discriminant of the quadratic equation, ax squared plus bx plus c equals 0. And you'll notice that basically the discriminant, d, is the part under the square root sign. So if d is positive, there are two different real solutions. That makes sense, because if I have a positive number under here, then I'm plus or minus a d, which is positive, so that means I have something plus it and something minus it, so that makes sense. If d is equal to 0, then there's one real solution, because that would mean that I have some number over here, my negative b is plus or minus the square root of 0 over 2a. So that would mean that I basically have negative b over 2a, right? So my vertex is exactly the same place as I hit is equal to my x-intercept. That means it only touches the x-axis once. Now, if d is less than 0, there's no real solution, because think about that. Negative b plus or minus a square root of a negative number, it's not going to be real. It's going to be, we're going to go back into the imaginary and complex numbers. And usually this is when, if we have our graph, this is when you have something like this. This occurs when we have something that touches there, like the vertex is right there, and this is just what we've been doing. It has two real roots like this. So here is exactly what I just said in a bigger graph. So type of x-intercepts, it crosses twice, touches the x-axis. So in other words, the vertex is the x-intercept. And here the graph just never crosses the x-axis. It always is above it or below it or something like that. And again, here our discriminant is positive. Here our discriminant equals 0, and here our discriminant is negative. And here we can either factor, if it's factorable, we might need to graph, or we can use the quadratic formula. Here we sometimes can factor, it's going to be a perfect square. We can graph, again, we can also graph. We can also use the square root method, because again, it's a perfect square, so the square root method is made for that one. And here we can use the quadratic formula. That's pretty much it. Quadratic formula, the other way to do it, well, you can use the square root method for when the discriminant is less than 0, but generally the quadratic formula is just a generalized form of the square root method anyway. So you might as well just use the quadratic formula. And the quadratic formula, and the thing I want to mention is the quadratic formula works for all of them. because the problem with here is graphing isn't going to do it. You can graph these, you're still not going to figure out what the zeros are because they're not real. So you're going to have to figure it out using the quadratic formula. So let's talk about the square root method a little bit. And that's odd that it didn't mention this one. Square root method also works for this. But looking at these two equations, x squared equals negative 36. So x is equal to plus or minus the square root of negative 36. No, I can't take that negative on the other side. So x equals is the square root of negative 1 times the square root of 36 plus or minus, remember this is I and 6, or, oops, forgot the equal sign, plus or minus 6i. And that's how we would write that. And similar to that, here's this one. So 3x squared equals negative 36. X squared, divide both sides by 3, equals negative 12. Now take the square root of both sides. Put the plus and minus. X is plus and minus the square root of negative 12. So that is the square root of 4 times the square root of 3 times the square root of negative 1. That's what x equals. So x equals plus or minus square root of 4 is 2 root 3 I. So that's how you would solve these two equations. So that would be easy to do it that way. There's no x term to get in your way. It'd be crazy. So now let's look at this one. Let's look at these two. Now, I happen to know that there is no way to factor these two problems, so we are going to use the quadratic formula. So here A is 1, B is negative 5, C is 7. And graphing and using your calculator is not going to help, because watch what happens when I try to do that. X squared minus 5x plus 7. And I'm just going to zoom to 6 standard. Okay, that's the problem. You can see the problem. It never touches the x-axis at all. So there's no way our calculator is going to give us this answer. So we have to do this using the quadratic formula. A equals 1, B equals negative 5, C equals 7. So we can do this by negative b plus or minus the square root. Remember, I want this in parentheses, b squared minus 4ac all over 2a. So I have positive 5 plus or minus the square root of 25 minus 28 over 2, 5 plus or minus the square root of negative 25 minus 28 is 3 over 2. So I'm going to write this using complex numbers. 5 over 2 plus or minus, and I write this as the square root of 3i over 2. And that's how I want this answer. That is written correctly because it's a plus or minus bi is usually how we write that in complex form. That is in standard complex form. Okay, because we have the real portion and the imaginary portion. And if you take a lot more math classes, you'll see what I mean. Okay, so let's look at this one. So this one is not written equals 0. So we're going to add both sides. And once again, this isn't going to work for us. We're not going to be able to use our calculator to do this. This has to be done using the quadratic formula. So A is 5, B B is 2, C is 5. So negative 2, negative B, plus or minus the square root of B squared minus 4AC all over 2A. Notice every time I'm putting parentheses in there, every single time. So that just becomes negative 2 plus or minus the square root 4 minus 4 times 5 times 5. 5 times 5 is 25 times 4 is 100 over 10. Negative 2 plus or minus the square root of negative 96 over 10. So 96, I know that's divisible by 16. So I'm going to rewrite this as negative 2 over 10 plus or minus the square root of 16 times the square root of 6 times the square root of negative 1. Put that over 10. So this becomes negative 1/5 plus or minus 4 root 6I over 10. And then these can be, so negative 1/5 plus or minus 2 root 6I over 5. Okay. So, like I said, what about our calculator? And what is going to happen when we try to do some of these with our calculator? Some of them can be done and some of them can't. So, if I want to see if it can be done, I can always check. X squared plus 10x plus 21. Let's look at that one and see if that one can be done. I'm just going to standard zoom in right now. Okay, can that be done on our calculator? Yes. What about this one? 7x squared minus 2x minus 2. Can that one be done on my calculator? 7x squared minus 2x minus 2. Graph. That one can be done on your calculator. Let's try this one. I'm going to put them on this side to make them all positive. So 0 is 8x squared plus 2x plus 13. Let's see this one. So we have 8x squared plus 2x. Let's go plus 13. Let's graph that one. Oop, you know what? I didn't have the plus. I'll go back and fix that. I have a typo that I happen to see in there. That is plus. Okay. So let's graph it. Okay, it's not showing me. So let's make sure that we have the vertex in there. So negative b over 2a. Well, we know its vertex is negative 1/8. So we definitely have the vertex is going to be like right here. But what we don't have is the height of that vertex. So what we know, since the vertex is going to be out here, and we know that it is a happy graph, then we know that if the vertex is way up here, for example, or way down here, I guess if it's happy, it's way down there, it could. So let's make sure that we didn't miss anything. So one of the things that I'm going to do is I'm going to bring my x in a little bit. So I'm actually going to make this 5 and 5. And let's take our y's out. I'm going to go all the way to 100. Let's just see what that looks like. Oops, did I make a mistake? And there it is. So I can see it now. Does it touch the x-axis? And the answer is no, it does not touch the x-axis. I didn't think it did. So since it doesn't touch the x-axis, we can't use our calculator to do that problem. This problem would have to be done using the quadratic formula to find the zeros. They're no x-intercepts. To find the complex zeros of the problem. And so that is it. And I know I went over an hour again. I'm a horrible person. So I hope you got a lot out of this, and I'll see you guys in class.